Overview and objectives. Electricity plays a very important role in our daily lives. It lights, heats and cools our homes and also performs a number of routine jobs for us. Most of the charm of modern life would be missing if there were no electricity. Let us now learn something about this most important source of energy and the things associated with it.
Papa, Deepavali is nearing. Shall we decorate our house using these lights?
Sure, my dear.
Papa, this serial set is not working. Please check it, Dad.
It cannot be repaired because it is connected in series, and even if one bulb fuses, the whole thing will stop working.
What do you mean by connected in series?
I'll explain. Learning objectives. At the end of this lesson, you will be able to understand factors on which resistance of a conductor depends, resistance of a system of resistors, series and parallel circuit. Resistance. In a circuit, some materials allow flow of larger current through them than others. In other words, certain materials offer more resistance to flow of current than others. The property by virtue of which a material opposes or limits the flow of electric current through it is called its electric resistance. Electrical resistance is the property of the electrical element to oppose the flow of the current passing through it when a voltage is applied across the element. It is mathematically represented as the ratio of the voltage to current. R is equal to V divided by I, where R is equal to resistance, V is equal to voltage across the electrical element, I is equal to current flowing through the electrical element. The electrical resistance is measured in ohm. The unit is named after German physicist George Simon Ohm, who discovered the famous Ohm's law. Ohm is the SI unit of resistance. The Greek letter omega is used to represent resistance. Definition of ohm. 1 ohm is the resistance of a conductor through which a current of 1 ampere flows when the potential difference across its ends is 1 volt. Component that is used to resist the flow of electric current in a circuit is called resistor. In practical applications, resistors are used to increase or decrease the electric current. Variable resistance. The component of an electric circuit which is used to regulate the current without changing the voltage from the source is called variable resistance. Rheostat. This is a device which is used in a circuit to provide variable resistance. Conductors. Rate of flow of electrons in a conductor is electric current. The particles of conductor create hindrance to flow of electrons because of attraction between them. This hindrance or resistivity is the cause of resistance in the flow of electricity. The resistivity is the opposition strength of the electrical elements. Number 1. Substances which allow electricity to pass through them easily are called conductors. These are made from materials which have low resistances. Metals like copper, aluminium, silver, iron, brass and also salt solutions are good conductors of electricity. Number 2. Insulators. Substances which do not allow electricity to pass through them easily are called insulators. These are made from materials which have a higher resistance. Some substances like air, plastic, cotton, rubber, wood, paper, glass, pure water, etc. are insulators. Factors affecting resistance. Resistance in a conductor depends on nature, length, and area of cross-section of the conductor. Number 1. Nature of material. Some materials create least hindrance and hence are called good conductors. Silver is the best conductor of electricity, while some other materials create more hindrance in the flow of electric current, that is, flow of electrons through them. Such materials are called bad conductors. Bad conductors are also known as insulators. Hard plastic is one of the best insulators of electricity. Number 2. Length of conductor. Resistance R is directly proportional to the length of the conductor. This means resistance increases with increase in length of the conductor. This is the cause that long electric wires create more resistance to the electric current. Thus, resistance R is directly proportional to length of the conductor L, or R directly proportional to L, equation number 1. Number 3. Area of cross-section. Resistance R is inversely proportional to the area of cross-section A of the conductor. This means R will decrease with increase in the area of conductor and vice versa. More area of conductor facilitates the flow of electric current through more area and thus decreases the resistance. This is the cause that thick copper wire creates less resistance to the electric current. Thus, resistance R is directly proportional to 1 upon area of cross-section of conductor A, or R is directly proportional to 1 by A. This is equation 2. From equation 1 and 2 we get R directly proportional to L by A. That is equal to R is equal to rho multiplied by L upon A. This is our equation number 3. Where rho is the proportionality constant, it is called the electrical resistivity specific resistance of the material of conductors. From equation 3, Ra is equal to rho multiplied by L. This gives rho is equal to R multiplied by A divided by L. The SI unit of resistivity. Since the SI unit of R is ohm, SI unit of area is meter square and SI unit of length is meter. Therefore, unit of resistivity rho is equal to ohm multiplied by meter square divided by m. This gives ohm meter. Thus, SI unit of resistivity is ohm meter. Materials having resistivity in the range of 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter are considered as very good conductors. Silver has resistivity equal to 1.60 multiplied by 10 to the power minus 8 ohm meter and copper has resistivity equal to 1.62 multiplied by 10 to the power minus 8 ohm meter. Rubber and glass are very good insulators. They have resistivity in the order of 10 to the power 12 ohm meter to 10 to the power 17 ohm meter. Resistivity of materials varies with temperature. Resistance of a system of resistor. Resistors are joined in two ways, namely in series, in parallel. Resistors in series. When two or more resistors are connected end-to-end consecutively, so that the same current flows through all of them, then the resistors are said to be in series. A series circuit has one path for the electricity to travel through. In series combination of resistors, the current is the same in every part of the circuit or the same current throughout the circuit. Law of combination of resistors in series. If two resistors R1 and R2 connected in series, a battery of V volts is applied to the end of this series combination. Let the potential difference across R1 as V1 and that across R2 as V2, since V represents energy. according to the law of conservation of energy. V is equal to V1 plus V2. This is equation 1. That is, the total potential difference across the two resistors should be equal to voltage of battery. Using Ohm's law, V is equal to IR. This is equation number 1. V1 is equal to IR1 and V2 is equal to IR2. This is equation 2. When I is the current flowing through the circuit and R represents the equivalent resistance of the two resistances. Substituting 2 in 1, we get IR is equal to IR1 plus IR2. That gives R is equal to R1 plus R2. The equivalent resistance is the sum of the individual resistances connected in series. The above result can be generalized for n number of resistances of different values as R is equal to R1 plus R2 plus Rn. Resistors in parallel. When two or more resistors are in such a way that the potential difference across them remains the same, they are said to be connected in parallel. When resistors are joined in parallel, the reciprocal of total resistance of the system is equal to the sum of reciprocal of the resistance of resistors. That is, sum of the reciprocals of all the individual resistances. Law of combination of resistors in parallel. If two resistors R1 and R2 are connected in parallel to one another between the points A and B, connect this combination to a battery of potential V. Here the potential difference across R1 and R2 will be equal to battery voltage, but the total current I flowing in the circuit branches as I1 through R1 and I2 through R2. Since there cannot be accumulation of charges at any point, I is equal to I1 plus I2. This is equation 1. Using Ohm's law, I is equal to V upon R, I1 is equal to V upon R1, I2 is equal to V upon R2. This is equation 2. Substituting the values of equation 2 in equation 1, we get V upon R is equal to V upon R1 plus V upon R2. That is equal to V in bracket 1 upon R1 plus 1 upon R2. This is equation 3. On dividing equation 3 throughout by V, we get 1 upon R is equal to 1 upon R1 plus 1 upon R2. If the resistors are connected in parallel, the reciprocal of the equivalent resistance is equal to the sum of the reciprocals of all the individual resistances. This result can be generalized for any n resistors. Therefore, 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon Rn. Disadvantages of series connection and advantages of parallel connection. Disadvantages of series of combination. Current is constant throughout the electric circuit. Example, if we connect a bulb and a micro-oven in a series, it is impracticable because both of them need different values of current. If one component in series fails, the circuit breaks and none of the components work. Example, fairy lights. Lights used for decoration. All electrical appliances have only one switch, due to which they cannot be turned on or off separately. The appliances do not get same voltage as that of the power supply line. The overall resistance of the circuit increases too much, due to which the current from the power supply is low. Advantages of parallel. If one electrical appliance stops working due to some defect, then all other appliances keep working normally. Each electrical appliance has its own switch, due to which it can be turned on or off independently, without affecting other appliances. Each electrical appliance gets same voltage as that of the power supply line. The overall resistance of the household circuit is reduced, due to which the current from power supply is high. Summary. Diya, have you now understood what series and parallel connection is?
Yes, Dad. Thank you very much for patiently explaining it to me.
Children, we have thus come to an end of our discussion on series and parallel connection. Hope you have understood the same as Diya. Summary. At the end of this topic, we have learnt factors on which resistance of a conductor depends. Resistance of a system of resistors. Series and parallel circuit.